Okay. So on to day 2 of unit number 8. For you seniors, this is one of the last things that you'll have to worry about. This will be the last new notes that you have to worry about, etc., etc. Okay. So anyway, we're still working on hypothesis testing. Now we're actually going to do tests. Now remember, we've learned this before. We know what a z-test is. Z is the observed x bar minus mu over the standard error. In a lot of cases, it's going to be sigma over the square root of n, because we're not going to do just one test. Okay. Also, remember, this is a test for the mean of a population. Okay? Now, so if you're going to be doing a hypothesis test, there are 5 steps that must be followed through. Okay? So 5 steps for hypothesis test. 5 steps. Hypothesis test. Okay. First step. State the hypothesis and ID, or identify, the claim. And one of the hardest things for students is to identify the claim, but it's really, really easy. All right, 2, find the critical values. Okay. Part 3, compute test value. Part 4, reject or fail to reject the null. And then part 5 will be to summarize. And some of you still don't understand the importance of summarizing, but okay. So I'm going to pause this and write up our first example. You guys will show up right away. Okay. So we have a watch group claiming McFries have more than 7 grams of fat. A sample of 30 orders has a mean of 7.2 grams with a standard deviation of 0.5 grams, and we're going to do an alpha of 0.05. We're 95%. First step is to state the hypothesis and identify the claim. So when you're doing the hypothesis, you need to write down HO, the null hypothesis, and HI, the alternative hypothesis. Well, remember, the null hypothesis always has to have equal in it. Okay? So in this case, we're going to say that mu is going to be less than or equal to 7 grams. Okay? Which means our alternative is going to be mu is greater than 7. Why do I want greater than 7? Because I'm looking at the way the problem says. It says a watch group claims that it has more than 7 grams of fat. Okay? Well, if it's got more than 7 grams of fat, that's got to be one of the 2 things that we have. Mu is greater than 7. Mu is greater than 7 can't be my null hypothesis because I have to have an equal sign in there. Since I have to have an equal sign, then the null is going to be my less than or equal to. Hopefully that makes sense. Number 2 is to find the critical values. Oh, by the way, obviously this is the claim because it says it claims that it has more than 7 grams of fat. So I'm going to put a star next to HI. Now, we have alpha equal to 0.05. Now, we have greater than 7. If it's greater than, for HI, okay, that means that we have a one-tailed test, okay, and it's going to be a right-tailed test. Okay. So what we're going to do is we're going to look on our table and we're going to find our critical value. Our critical value is 1.65. Okay. So that gives me a z-score. So that is our critical value, 1.65. We're looking for something more or less than 1.65. If it's more than 1.65 and it falls in the shaded area, I'll tell you what to do there. And if it's less than 1.65 and it falls in the unshaded area, we'll tell you what to do there. Okay? So we actually have to find our z-score. Well, how do we find a z-score? Z equals observed, which was 7.2, minus expected, which is 7, over the standard error, which is 0.5, divided by the square root of 30. Okay? And if we do that carefully, we end up with 2.19. Now, what we need to do, we need to say, okay, is 2.19 in the critical area or is it not in the critical area? Well, hopefully you all can, compare, and you have 1.65, that's clearly less than 2.19, and everything to the right of 1.65 is greater, so this is in the critical area. So in the critical area, means that you have to reject the null. Reject the null. Okay? All right. Now, step number 5, because we've had, is to summarize, and some of you have, or some students sometimes have problems with the summary. It's really not as bad as you think it is. Okay. So basically, this is how it starts. We start by saying we either do or we do not have enough evidence. Okay. In this case, since we rejected the null, we do have enough evidence at alpha equals 0.05, because you always have to tell me what alpha was, to support a significant difference Okay. Now, there are other ways that we could write this, but you should start out, we do have enough evidence at alpha equals 0.05 to support. You could also say that McFries have more than do contain more than 7 grams of fat. That would be a best way of writing it. So instead of writing a significant difference, we would say to support McFries have more than 7 grams of fat. Okay. All right, it's that straightforward. Those are your 5 steps. Okay, well, let's do another one to show you give you the idea. So, second and last example problem. I was told the average cost of a round-trip ticket to Vegas was $225. When I checked prices from 35 different places, I found my mean to be $215 with a standard deviation of $25. Was I told the truth? Use alpha equals 0.01 or 99%. All right. Notice, in this problem, there is nothing that says that you're looking for more or less. You just want to know, is the average cost $225? So your null hypothesis, because it has the equal into it, is very simple. It's HO the mean, mu, is equal to 225. Notice again, I'm looking just for a change, okay? HO means there is no change. HI means there is a change. In this case, the change that we're looking for is any change. So mu is going to be not equal to 225 for HI. Okay? So for, in this case, we have HO equals 225. We have HI is not equal to 225. That's step one. Step two, find your critical values. Draw your picture. You guys are going to have to be drawing these pictures. You're going to have to get used to it again. All right. What type of test is this? If it's a not equal to, it is a two-tailed test. Okay, so it could be anywhere in either one of these two areas. Okay. Now for 0.01, as alpha is 0.01, remember, because it's two-tailed, we're going to be looking at 0.005 for our critical value. So our critical values are going to be plus or minus 2.58. So this is going to be 2.58 here. This is going to be negative 2.58. Now, going back to step 3, we need to find our actual z-score. Please, guys, set up the z-scores properly. Remember, it's always observed minus expected. What was observed? He found his mean to be 215, so it's going to be 215 minus 225. Some of you told me that z-scores, some of you told me on the last test that z-scores can't be negative. Yes, they can. Okay. So 215 minus 225 divided by the standard deviation, which was 25, over the square root of 35. If you do your math carefully, you should get negative 2.37. Now, where does negative 2.37 lie? Well, negative 2.37 is somewhere like around here. All right, so is that in the shaded area? No, it's not in a shaded area. It's not in the critical area. So what does that mean? If it's not in the shaded area, then we fail to reject the null. Okay, so basically we're going to say fail to reject. One of the things I just realized I forgot to say. Let's take a look at what HO and HI were again. HO said that mu was equal to 225. HI said that mu was not equal to 225. Which one of these is the claim, guys? You were told that the average is 225. So guess what? The claim is the null hypothesis this time. Okay, so now we've done one where it was the alternative hypothesis. This one's a null hypothesis. Okay, when you write your conclusion, you always write it based on the claim. Okay, so we have failed to reject the null. We do not have enough evidence at alpha equals 0.01 to reject that the average cost of a round-trip ticket to Vegas excuse me, is $225. Couple things, and I'll give you my nice little saying that Mr. Kronk likes to tell everybody. When you're writing your conclusion, you always base it off of your claim. The last time our claim was HI. So since our claim was HI, we're either going to support it whenever we get to this part, it's going to be support. Okay. If it's HO, whenever we get to this part, the word's going to be reject. So in other words, you reject the ho and you always support the high. So you always reject the ho, always support the high. It's actually funnier in person. Anyway, and so it's very straightforward, your conclusion. You either do or do not have enough evidence, and you either reject if this is HO, the claim is HO, or you support if the claim is HI. That's it. Don't be trying to change things around and trying to write the same thing different ways. It makes life a lot more difficult for both you and me. Anyway, so that's all I wanted to show you today. I'll give you some problems on this tomorrow. And, on Friday, I'll probably give you a video of section 1, where the stuff that I gave you on Tuesday. So you can see how well you're doing. All right, guys. Enjoy your day.